Okay, so first step is to set up the Raspberry Pi with the necessary dependency, which is Nextmon for CSI data collection. So I'm using this GitHub link, wireless eye, and here we see what the prerequisite is to have the Nextmon firmware on it. So if I go down here, I just followed the instructions to set up the Raspberry Pi with Nextmon for CSI data. And then in the terminal, I SSH'd into the Raspberry Pi. And I can check if I have it on there, and I do. For the next step, I just cloned wireless eye and ran the basic functionality on the Linux system. So here I can start from scratch. So I run this. This is what opens up. I'm going to make this a bit smaller. So here under settings, it's 10.0.0.184 for my Pi. And then I changed this to 20, 20, and 20. And this is based on the instructions that were here. Okay. And then once I did that, I can go to visualization. And then here, I can see if there's any data. Let's see, connect. Okay. So we start seeing that CSI data come through, like so. For this project, one important step was to get the pre-trained YOLO model for fall detection. And here it is. Let me go here. Okay. So basically, I'm using YOLO version 8, and then opening up the camera, recording, so when I press R, it starts recording, and then I'm capturing also timestamps here. And if I just scroll down, we see that it continues to record and capture if it's falling or standing. And then I can quit out of it whenever I want. Okay, so for example, here I can run this. So once I get this, I can start recording, and it will capture the timestamps as well. So I could be here. I can press R a few times sometimes, but it should change to recording. So now it's recording, and it's capturing when I am standing, or if I lay down. When I am laying down, it should say that I have fallen. Yes. Okay, so there's two ways that I capture the data. One is automatically, the other one's manually. For manually, basically I just lay down next to the Raspberry Pi. So I press record while laying down, like so. So I'm laying down now, and then I press record, and then I press stop. Now I see after laying down and pressing record and stop, I have this data point, and I can label that as laying down. And then I would do the same thing for standing. So I would just stand up next to the Raspberry Pi, and then I would press record, and then stop it, and then label that. Okay, so for automatic capture, what I did is I started recording CSI data, and at the same time, I run my YOLO model here. So I run this, and now it starts to capture, and then I have to make sure to press record. Okay, now we see that it is recording right here. And once it does that, then now I am recording here, and I'm also, so I have timestamps here with the YOLO model, and then I'm also running and recording here. So what I did is just stand next to the Raspberry Pi. That would just stand and then lay down like so. And I did that 25 times while running the YOLO version 8, and also making sure I was recording the CSI data. So then I stopped this and quit here. Okay, so for the automatic data capture, I had the CSV file with all the CSI data, and then I had the fall detector YOLO version 8, and I basically took what YOLO version 8 had detected in terms of standing or fall detected, and I matched it with the same timestamps as the CSI data that I had recorded. But to do that, there were some issues in terms of timestamps, so I had to match them up. So that's basically what I'm showing here. I had to make sure that the timestamps were loading in properly, so that the CSI data could have a new status column that would show if a fall was detected or not. Like so. And then once I did that, then I just created some groups from that one big file. So in increments I did, if there was a big chunk that said fall detected, that would be one CSV file, and then if standing came up as a status, that would be another CSV file, and that's how I got all of these CSV files for automatic detection, and they're all here. Okay, so in wireless eye under scripts, there is model generation and real-time classification example. I use that for my purposes here. So what I'm trying to do is I was looking at falling versus standing. So first going through the build class, getting the data, getting the window over the data here, splitting it into chunks, and then here is just balancing it between the falling and the standing data. And then down here, just loading in the data and then splitting it into train and test data, like so. And then here, creating the windows for test and train splits. And here is the output of that. And then down here is the 1D CNN. And here we're building and training the model. And here is the accuracy. So it's 0.7, so 70%. And then evaluation. So just plotting the training history, the ROC curve, the confusion matrix, and then some metrics. And here's the output. So here, accuracy, we see that the training accuracy is increasing and the validation accuracy is also increasing. The loss is decreasing for both, slightly less so for the validation, but it's still decreasing. And then the ROC curve, we see that the area under the curve here is 0.74, which is good. And then down here is the confusion matrix. So we see that it's predicting properly in 243 plus another 109. And then it's erring on the side of saying that someone's standing. So for example here, they have fallen, but it's saying that they're standing. And for my purposes in this project, it's better to err on the side of standing because we don't want to call the authorities when it is not needed. And then here is the F1 score of 0.77, which is it's weighing the accuracy of saying that they have fallen versus triggering it when they have not. Okay, now for real-time inference, getting the window now in real time, and then the predict files. So here, basically watching the CSV file for changes. If changes are detected, then we are running it on the last 3 seconds in the updated file. So here it is for real-time classification, and here's the output. Okay, so for time's sake, I will only run the automatic one, but basically I can change this. These are the automatic data points, but I can change it to one I had just done it manually and labeled it myself here. So I would just change that in here and then run the manual versus the automatic, but right now it's set to the automatic one. Okay, so now I just ran the real-time inference. And I'm recording, and now I'm standing next to the Raspberry Pi, so prediction should say stand with the confidence varying, but we see about 60%, like so. And then I'm going to go lay down next to it. We see fall at 90% after laying down. I'm going to try to stand up more time. Fall should go down now. And we should start to see stand again. So we see fall going down. And standing coming up like so.